Good afternoon, everyone, and welcome to Funding Sustainability, a roadmap to accelerating ESG and IAQ initiatives. My name is Ava Montini, and I'll be your host for today's webinar. We're here today to address a critical and timely opportunity: how to accelerate energy efficiency and sustainability goals by leveraging grants and financial incentives. Buildings are at the center of the energy conversation, accounting for 40% of global energy consumption, with your building's HVAC system alone counting for 35% of that. At the same time, poor indoor air quality imposes a staggering cost, an estimated $168 billion annually in lost productivity and healthcare expenses. But here's the good news. With the right strategies and tools, we can flip the script. Today's session will guide you through actionable insights to make impactful upgrades to your facilities. We'll discuss how clean air intelligence can create healthier, decarbonized environments while enhancing energy efficiency. You'll learn about practical, sustainable approaches to low-pressure filtration solutions that tackle one of the largest financial and operational bottlenecks in HVAC systems. And finally, we'll dive into the grant application process itself, breaking down how to identify opportunities, calculate energy savings, and align projects with funding requirements. Our goal today is to show you how these elements come together to empower healthier spaces, align with ESG goals, and reduce energy costs, all while building a more sustainable future for your facilities. Now, let's meet our panel of experts who are going to guide us through today's session with their unique perspectives and expertise. So first, we have EC, co-CEO of Poppy. Poppy brings clean air intelligence, empowering building owners to create healthy, decarbonized environments while achieving the highest standards of energy savings and occupant health. EC will show how their patented air tracer technology offers actionable insights for optimizing indoor air quality and also energy performance. Next, we're going to hear from Macey, a junior engineer at Blade Air. Macey will talk through practical strategies for integrating sustainable low-pressure filtration solutions with grant support as well. She's going to be walking us through one of our new tools, Blade Air's Energy Grant Interactive Map, that helps identify funding opportunities tailored to your region with also regular update options. And finally, we're going to hear from David, principal at the Aquila Group. He brings deep expertise in navigating the world of energy grants and incentives. And in his session, he's going to be reviewing, like I mentioned earlier, how to calculate energy savings, align with green projects with grant criteria, and also avoid some common pitfalls that providing you with a clear roadmap to maximize the impact of your sustainability initiatives. Without further ado, let's dive into our first presentation. EC, over to you to kick things off.
Thanks so much, Ava. Thank you for hosting, and thank you everybody for deciding to spend a little bit of time with us today. It's an absolute pleasure to be able to kick things off. We have a couple of great speakers and very happy to also answer your questions towards the end of the session. But a little bit quickly to start off, who are we? Who's Poppy? My name is Elizabeth Caley, and I'm the co-CEO of Poppy. We actually started the company 5 years ago with the goal to help people who own buildings, maintain buildings, make recommendations, and help build out new construction to basically make sure that their buildings are as healthy and as sustainable as possible. And that's really what drives us and our entire team. Very briefly, the focus, especially over the last year or two, is about how do we make sure that people are optimizing their indoor air so that they can decarbonize and enhance their sustainability. So basically help with their operational carbon and hit the targets that they've set for themselves as individuals or for themselves as an organization when it comes to CO2. And then obviously that what comes along with that when it's all done properly is that all of these energy sustainability projects end up saving the buildings and the building operators a lot of money. And then at the baseline of what everything we do is make sure that nothing is higher than making sure that the occupants of those buildings have healthy, clean air. And What has really been a turning point has been a couple of new standards that have been ratified over the last 12 months that a lot of people aren't aware of. So I'll spend a little bit of time talking about that, a little bit of time about how we've been implementing those techniques in Ontario in lots of different types of buildings and what the results of those have been. But first, quickly to sort of level set everybody on indoor air quality. And I know this is probably basics for many, many, many of you, but just so we're all speaking from the same page, indoor air quality has traditionally been measuring the same couple of things. And so there's lots of different sensors that are available out there, ranging from very consumer grade sensors that you can buy off Amazon to higher grade, higher quality sensors, specialized providers that get installed in your building, get hooked up to your local internet or Wi-Fi, and basically have a continuous monitoring of the same couple of things: temperature, relative humidity, PM, or essentially the relative abundance of particles at different sizes. And then depending on the sensor, CO2, or some sort of proxy that measures CO2 using VOCs. And those are this is an example dashboard that you would typically see if you have an installed IAQ system, say in a commercial building, and you can monitor how all the various parts of the building are performing at any point in time. Typically, the scores or the scores for all of those different measures are aggregated into some sort of simplified index or air quality index. And the goal here is primarily around occupant health, as you can imagine. The challenge when we've been talking to people, especially over the last 5 years, is that indoor air quality is great if you don't have anything else to know about your building, but it falls short in a couple of different areas. And so this was really one of the reasons why there's a lot of work with a lot of standards bodies to try and evolve what we want to measure when it comes to indoor air, so that it's more relevant to some of the largest threats to buildings and occupants. So first of all, IAQ typically did not move the needle during the pandemic. It doesn't really move the needle on the flu season. We hear over and over again, okay, this is great. I have all this data now, but what do I actually take action on? If something goes into the red, what do I do? What it doesn't measure are things like viral particles, things that are transmitted through the air from a sick person in the building, when there's always a sick person in the building these days, and how likely other people are to get sick because of that. So that's not something that is measured using traditional IAQ. It also doesn't help you prepare for wildfire season if that affects your area. And unfortunately, we found out in Ontario that could become more and more common for us. But it will tell you if during wildfire season how many particles of different sizes are actually in the building, but it doesn't help you tell how well the building will handle when this happens, so you can actually prepare in advance. And it also doesn't help with energy savings or energy optimization of your building and your HVAC system, your ventilation system, which is a large part of what we'll be talking about as a group today. So the great news is there have been some amazing breakthroughs, both on the technology side and on the standard side, that help fill in those gaps and are really exciting to talk about. The first one is a new standard that came out from ASHRAE, which is the international standards body that of engineers and experts that really come together and through a very consultative process, figure out what are ways that we want to manage our buildings. So 62.1 might be an ASHRAE standard that you're familiar with. It essentially it dictates how much CO2 is okay in a given indoor space. ASHRAE released standard 241 last year, and this was basically because the White House asked the group to do this to address those couple of gaps that we had talked about. So specifically about infection control when there's people who are sick in the building with things that can be transmitted through the air. And then very importantly, actually build the standard so that it's based on occupancy. So the standard or how much effective clean air a building requires under a standard like 241 changes depending on how many people are in the building. And that could be dynamically, if you have an occupancy sensor, you know exactly how many people are in different parts of the building at any point in time. But that can also just be using the standard to say, the peak for this classroom or this courthouse or this floor of this office building is X number of people. And so we're going to use the standard to figure out how much effective clean air is needed in that building or at that particular part in the building. So 241 was a great breakthrough. It's becoming, much better understood. There's a lot of content out there that will help you understand it in detail. I just want to highlight one part of it, which we were very lucky to be a part of, which was figuring out an easy and inexpensive way to test your effective clean air in lines with this standard. And that's using Appendix C of the standard itself, so you can read all about it in there. But essentially, think of it as a fit test for your building. So a best way to know if we're going to be able to handle something as human beings is putting us on a treadmill and measuring how well we do. So what this test, this tracer particle decay testing does is it introduces healthy, perfectly safe particles into the air and then measures how well your systems in the building actually handle that and clear it. So it's a challenge-based system, and it's something that's very easy to implement, and you don't need an installed system to do. You can do it using a portable test, which I'll show a little bit of video later of how that works. But it's a great way of really getting a sense of how well not only the whole building's performing, but how individual areas of those buildings are performing, especially in the breathing zone. So where we're typically breathing, which is usually 3 to 6 feet off the floor. So what does it mean when you actually get the results from a 241 test, like the Appendix C test? Typically what we find, and we've done tens of thousands of these tests now all over the world, but a lot of them in Ontario, a small percentage of them are actually on target. So for the number of people in that space, and then the guidance based on what type of space it is, we have definitely some parts of buildings that are actually exactly right on target. Nothing should be done to change those. You just basically want to monitor it on an ongoing basis and make sure that doesn't change. Typically what we find, though, is that parts of buildings are in one of the other two categories here. And so below target is essentially there's not enough effective clean air reaching that part of that space in order to support the number of people that are typically in that space. And so we call that below target. And there's a lot of different things that can be done, a lot of different great solutions out there that can help improve that and help make sure that the minimum part of the standard is met. Very typically, especially in commercial office buildings, but in lots of different types of buildings, retail and warehouses and all sorts of other buildings, what we find is way more of the space is typically above target. And those are areas where there's potential energy savings that can be had. And with energy savings are cost savings, and those cost savings can be then reapplied to help any of the areas of the building that are below target. So just a quick snapshot of the kind of data that we're talking about. So we've performed not only 1,000 ASHRAE tests, but many tens of thousands now of the tracer decay particle tests. And in pretty much every space type you can think of. I think we've done jail cells now. I think we've done almost everything except for an operating room. And typically what we find, especially in newer buildings, Class A, Class B buildings, is that they're typically 2.5 times above what is needed based on the occupancy that is being supported in that space at that particular point in time, which makes sense. A lot of the buildings that we're occupying, they're engineered to support a very large number of buildings, and a lot of buildings, especially office type buildings, are operating at a much lower occupancy right now. But the systems have not been adjusted to essentially account for that, and so there's a lot of energy waste. So here's a very short snapshot of the kind of data that you get once you do a test like this. A very typical building where test in 30 different parts of the building. And in this building specifically, I believe this one was in London, Ontario, that 77% of the areas tested of those 30 tests done were well above what the standard requires. 10% were right on target, and a few of them were low based on the occupancy, but only off by a little bit. So if the room was reduced the occupancy by 1 or 2 people, then they would have passed. And here's sort of a detailed view of what that might look like in a report. And everywhere you see blue, that's a place where there could be energy savings for that floor or for that area. And the standard, like I mentioned briefly earlier, it depends on what how the building is being used or how that part of the building is being used. So there's more clean air required, for example, if it's a fitness center or somewhere where food is being prepared, than if it's a place where people are, sitting or doing some of those more regular things. So let me quickly just show you what a test looks like. Here's the Royal Ontario Museum, the ROM, in Toronto, where as part of a citywide survey that we did at Poppy, we measured hundreds of buildings in Toronto with our portable system. And essentially, it's a quick setup where we go in, we add particles into the air, which is what you're seeing here. And then the sensor array is outlined based on the standard. And basically those sensors are now collecting data from within that space so that we know exactly how much air is clean air is being applied or being delivered to that particular part of the building. And they're quick tests that once that test is done, then it's basically picked up and moved to a different part of the building. And typically in a day or two, even very large buildings, we have all of this data to provide, and nobody has to install anything. Nobody has to go through information like security checks because it's an entirely self-contained system. So what happens when you get these kinds of results? Here's an example of 6 types of buildings that we've done recently, a lot of these in Ontario, including courthouses. We've done schools. Just one moment. If any of you are like me, you probably have to operate as a door person for your dog every once in a while. Sorry about that. So these are 6 buildings and just some typical results we see. So the courthouse on the end of the list here, we weren't expecting to see a lot of places for energy savings. It was an older building with older systems. And this is an Ontario-based courthouse and jail, holding cells and those sorts of things, and offices that were all connected. But they wanted to make sure that their building was operating based on the latest standards for health. They were very pleasantly surprised that we found a great ROI and some cost energy savings that they can then use to apply to parts of the building. Those dollars they could save in their energy bills and apply that to some improvements in other parts of the building. And that's sort of the worst case scenario we typically see. And especially more modern buildings, there's usually a lot of energy savings and money there that can be saved. So up to, I think we had 1,000 metric tons in an office building that was about 450,000 square feet, about $250,000 worth of energy savings for them in a given year. It obviously varies based on your energy rates, your utility bills, et cetera. But this is the kind of analysis that we do, both with our measurement, and we also help organizations analyze their entire portfolios even before we step into the building, to help prioritize which ones might have the highest potential energy savings available to them. And then we focus on those buildings for the initial tests. So just bringing it back to Ontario and Ontario funding a little bit, there's lots more that I know you're going to hear from the other speakers today, but I wanted to just highlight one example of the Ontario Trillium Foundation, who have capital grants, especially for community spaces. And this is the kind of thing that they have stated many times in the past, in improving the clean air within the building is something that they will support up to $200,000 per year. The next deadline for applications is March next year, and we're very happy to work with any organizations if this is something you're interested in. What we can do is we can come in and actually do a baseline assessment of the building and give you some great quantifiable information of where improvements might be needed and or where places energy might be saved using our data. Then typically we also go in once adjustments are made and we'll do another set of tests and we'll show people that they've actually achieved their goals. So we're the numbers people. We don't actually provide the adjustments or the solutions that would be implemented, but we are definitely the folks that will show you what areas need attention and by how much, make recommendations, and then help you verify that those goals have been achieved. And last, but certainly not least, this is not a grant that's available in Ontario, but it is sort of a call to action. The Ontario Clean Indoor Air Act is something that is being called for by many organizations. I'm just highlighting the Ontario Society for Professional Engineers. Essentially, the Johns Hopkins Center for Health Security has built a model health act for indoor air, clean indoor air, that is basically available for any community, province, city to enact. And this is one that, if you feel so inclined, if you reach out to your local MPP and say that this is something that you would support in your community, it might help speed up the process of something like this getting enacted in Ontario. And that would improve everybody's life. So with that, I'm going to stop sharing and hand it back over. I'm very happy to answer any of your questions as we get towards the end of the session.
Thank you very much. And we're going to shift our focus now to filtration. Macey is going to guide us through sustainable low pressure filtration solutions and how they can be paired with grant funding to address some of the biggest challenges in HVAC systems. Over to you, Macey.
Just again, I'm Macey Clandfield. I'm working as a junior engineer with Blade Air, and today I'm going to be going into a little bit of detail on filtration solutions and energy grants. So before I get started, I just want to preface by saying my goal at the end of this presentation is to make it clear to everyone on how some separate ideas and different types of information actually fit together as essential pieces of a larger vision, which is to answer the question, how can energy efficiency and indoor air quality be transformed simultaneously through energy grants? Because a lot of the time these can be viewed as separate ideas, but I kind of want to bring them together and see how you can leverage both of these things through energy grants. Now, what are the different pieces that we're going to look at? First of all, why grants, some of the benefits that might be overlooked sometimes on grants, tackling retrofitting in the real world, why targeting filtration specifically is a good strategy to approach indoor air quality with energy efficiency, the roadmap to success. We're going to look at a success story, a little case study, and then getting started. To start, I just want to talk about some of the main benefits that you can get from using grants. I'm sure the first one that comes to mind is that financial relief, which you're going to get lower upfront costs and help make sustainability accessible. And actually, Ontario specifically, in September of 2022, the provincial government increased their funding for energy efficiency programs by $342 million. This means that actually the total funding was brought to more than $1 billion over the current framework. So I just wanted to point that out to show how much money is actually being put into these programs and how much is available to use to get these energy efficient upgrades. Now, once you actually have that financial support, another thing that is available through some of the grant programs, which is great, is you also get some technical support or guidance. This can include, depending on the program, things like audits, energy assessments, consultations, which can just help guide you through the process. And this support also helps you understand not only where you can make the most significant improvements, but how to optimize effective implementation. Moving on to the next one is actually, once you get this financial and technical support, you'll likely also align yourself or your company with ESG and sustainability goals. So businesses using these grants to implement energy efficient upgrades, you'll likely become eligible for some green certifications such as LEED or BOMA. If you're familiar, those are common certifications, which essentially enhance your market profile and demonstrate a company's commitment to sustainability. The next one, which I think can be overlooked sometimes, especially if we're looking at energy efficiency through the lens of filtration and indoor air quality. And not only are you going to be improving the energy efficiency of the building, but actually the quality of the air inside. So there was actually a one-year study done by Harvard, done across 6 countries, that found that there were 2 things. So first of all, a higher level of PM 2.5 particles, which are a common pollutant in the air that we breathe, in combination with lower ventilation rates, which was indicated by if there's a higher level of carbon dioxide in the air. The combination of these 2 things actually led to slower response times and reduced accuracy on cognitive tests. So by upgrading to energy efficient filters, you're actually going to be improving the productivity and improving employee satisfaction and retention. Moving on to long-term and compounded savings. Finally, grants actually offer long-term and compounded savings. This can include things like reducing your operational costs, lower utility bills. Through the low-pressure filtration, which we'll get into, you can actually reduce the strain and extend the lifespan of some other components of your HVAC system. So while the grants may help make immediate improvements like we see with that upfront costs, they also set you up for long-term financial benefits. Now, when I talk about energy efficient upgrades, what does that actually mean? And what are some of the implications in the real world when we talk about retrofitting? One of the main things that we see is a lot of the buildings that we have today are older buildings that weren't built with energy efficiency in mind. And older buildings actually consume 25 to 30% more energy than newer modern buildings. Because of this, they're actually one of the keys to reaching these sustainability goals, because upgrading those buildings are going to have the greatest impact. One thing when we come back to grants is that actually leveraging these grants allows you to prioritize retrofits, minimizing structural changes. So you can choose specific type of equipment upgrades that will allow you to not interfere too much with those aging infrastructures that may have historical significance. The next one, being intuitive, is that financial support. Financial and regulatory challenges are a common issue when we talk about retrofitting, but again, grants help reduce those financial risks. And another thing about grants that is nice is a lot of the time they actually offer the flexibility to stagger these upgrades over several years, making the process more manageable and cost effective. The last thing I want to point out on this slide is a lot of the time when we talk about retrofitting, we look at one specific type of equipment that we're going to upgrade within the HVAC system. But it's important to zoom back out and see how maybe just upgrading one piece of equipment not only impacts the overall sustainability of the HVAC system, but of the building itself. And a way I like to think about this when we talk about air quality and energy efficiency, kind of the intersection of those two things, is that you're not only making your building healthier through energy savings, but you're also going to make a healthier environment for the occupants or tenants, employees that are inside that building as well. Now we're going to dive a little bit deeper into low pressure filtration and some of the key benefits and reasons why it's a strategic approach to get that energy efficiency and energy savings while also prioritizing your indoor air quality. The first one being system performance. So this one is actually at the heart of the filtration first approach. One thing I want everyone to consider is, in a scenario, there's so many different types of equipment you can upgrade in an HVAC system. So for example, if you were to upgrade your fans and you don't upgrade your filters, you're actually still going to get that same airflow bottleneck, keeping your system under unnecessary strain. So the importance of upgrading filtration is very great. And I'm sure as the most intuitive system impact you're going to get is that advanced filtration. So you're going to be able to capture particles that are a lot smaller. You're going to be able to capture more particles because often a lot of these low pressure, more energy efficient filters have longer lifespans. So you're going to reduce the frequency of your maintenance that you're having to change out these filters. And one thing I want to come back to Poppy's presentation a little bit and just emphasize that the importance of monitoring it, because with these indoor air quality monitoring systems, you actually have that visibility, because sometimes, unless maybe the air quality is really bad, it's hard to tell just by breathing the air how clean it is or how polluted it is. So you can actually have that visibility and measure and manage performance in real time with those data-driven insights to ensure optimal air quality. The next area is cost and savings. So when we look at all the different types of equipment upgrades that you can do for HVAC systems, for example, compressors, coils, fan replacements, filters are going to be one of your most cost-effective solutions. They're also going to result in other savings. So if the air you're then pushing through your duct is cleaner, you're going to reduce your coil and duct cleaning. You're going to be able to run your motor with less pressure and just reduce the overall strain on your HVAC system. And not only are those savings going to be pretty significant, which we'll get into in the case study, but they're going to be immediate. So from the moment that you take out your used filter, your standard, and put in a low pressure energy efficient filter, you're immediately going to see that reduced strain on your HVAC system, and you're immediately going to see that increased airflow. The last thing just to quickly touch upon is the execution efficiency. So again, compared to other types of upgrades, for example, installing a variable frequency drive in your HVAC system, often involves significant cost, but also significant downtime. Whereas if you're using a filter that's designed for zero retrofitting, you have minimal operational disruption. Also meaning that you should be able to replace your existing pleated filters with these zero retrofit filters, regardless of the HVAC system age, type, or size. I just want to take a moment to kind of come back to this idea of when we keep talking about low pressure drop filtration results in energy savings. What are the key things and contributors to this overall reduction of energy usage? When you put in a lower pressure drop filter, essentially that means the fan pushing the air through your building doesn't need to work as hard to push the air through the system. So that's where you get your reduced fan power requirements. And then kind of building on that, you can also get shorter fan run times. And this is because, again, from that reduced resistance across the filter, the HVAC system can actually achieve the required airflow of the building more quickly, so the fans can power off sooner or just lower operational cycles. The roadmap to success. This is just a general overview of kind of how you get from that point of wanting to leverage grants. And I know it can be daunting or may seem overwhelming, just even trying to find what grant you want to use. So I'll get into that a little bit more when we talk about Blade's new interactive tool that is actually live on our website. So I just wanted to point that out. And also in Ontario, often a lot of these programs allow for what is called the stacking of rebates. So this means that you can, for one specific project, there's the possibility to get funding from multiple different sources. And I know it may seem like a long process, but it really isn't. And I hope Akila, when they talk, I'm sure they'll demonstrate and go into the weeds a bit more about providing advice on calculating energy savings and just navigating this whole process to maximize your funding. Now getting into a case study. So Blade Air is actually very proud to have worked on this project in collaboration with one of Canada's leading national banks. And I'm excited to actually share this story with you all today. So where does the story begin? The story begins when this national bank wanted two things. So first of all, they wanted to improve their indoor air quality, but they also wanted a sustainability initiative. And they knew that they couldn't achieve this with their current filters, which were standard MERV 8 pleated filters. And essentially what happened was, by replacing all of their MERV 8 filters with the Blade Air Pro filters, we saw these key results. So energy reduction, a fan motor consumption reduced by 31%, airflow improvement, so improved and increased airflow by 25%, and then through that sustainability lens, greenhouse gas emissions reduced by up to 1,861 tons. So you can see the impact that those have, and actually the bank is deploying the Blade Air Pro filters across branches based on a sustainability initiative. So they're actually starting with locations across Canada that have a dirtier grid because they're seeing such a greater impact from those locations. And I think the importance, again, of just telling this story and explaining this case study is when we talk about energy efficiency, but then that intersection with indoor air quality, you're getting a twofold benefit where you're not only getting those greenhouse gas emission reductions and energy savings, but you're also making a healthier environment for the people inside the building and improving your indoor air quality, which you can't really put a price on that. Now, coming back to how to identify how to get started, I want to talk a little bit, and I'll jump into a demo, but this is Blade's new interactive map tool. It's live on our website, and essentially it's going to allow you to easily discover energy grants and funding programs that will enable you to upgrade your HVAC systems and improve your indoor air quality. So this is the Blade Air homepage, bladeair.com. So once you come here, you're going to scroll down where it says Unlock Energy Grants. Let's explore savings. And what's going to happen when you come here is you're actually going to be able to click on any of these areas in this map. So any of the provinces, any of the states. Let's try clicking on Ontario. And once you click on that, what's going to happen is there's going to be a list that pops up of the region, the name of the program, the type of program, and then also a link. So if there's one specifically you're interested in, or you just want to do a bit more investigation about maybe the funding details, the application process, the eligibility criteria, etc., anything like that. And another great thing is this notify me button. So if there's a specific area that's relevant to you, you can click, fill out your information, and get actually immediate notification when there is new grants. One other thing I just want to add about this is the importance of this notify me feature, because it ensures you don't miss out on opportunities, and it actually allows you to tailor the regions that are relevant to your companies or your specific goals. And it saves you the time and effort of constantly having to check for these updates, because it can be time consuming to go through and even know what is the right ones to be looking at. And another important benefit is when you get these notifications, you're going to be actually among one of the first ones to know about these grants, which increases the chances of you actually securing this funding before, for example, deadlines or quotas are met. Before I wrap it up, I just want to re-emphasize, I think Ava mentioned a couple of these stats at the beginning, but the global impact that HVAC has on energy consumption. So the first one being buildings are responsible for 40% of global energy consumption. And when you really think about that, it's quite a large percentage. Now combining this with the idea that HVAC systems account for 35% of a building's energy consumption, when we combine those two numbers, we actually get that HVAC systems alone account for approximately 14% of global energy consumption. So I just want to kind of share this and emphasize this information to show that leveraging grants helps make sustainability affordable, but also that implementing these low pressure filtration and energy efficient upgrades will actually allow you to have a meaningful impact in helping reduce this energy consumption. Now, to wrap it up, I just want to say thanks so much for taking the time out of your day to attend our webinar. I hope you've learned something, and I want to come back to that slide I had at the beginning where I overviewed with kind of the different puzzle pieces. So now that we've reviewed each piece of the puzzle and put them together, so looking at grants, real world retrofitting, filtration, real world success stories with our case study, and that interactive map tool, I hope it's clear not only just how important, but how attainable a sustainable and healthy indoor environment can be.
Now I'd like to reintroduce David. He's from the Aquila Group, and he's going to be showing us how to calculate energy savings, dive a little bit more in that world of grants and incentives in a little bit more depth, and navigate that whole application process to maximize funding opportunities. So over to you, David.
Okay. Well, thanks so much, Ava and Blade Air for putting on this webinar. My name's David. I'm just going to dive first right into the world of incentives and grants in Canada. Everyone here may always be wondering why energy incentives are so confusing. And I've been in the incentive world for over 15 years, starting in Toronto Hydro in 2008, and it is continues to baffle me how complex it is. So what you're looking at here is a graphic here that shows an example of where funding is coming from. So typically what you'll see is you have funding coming from the federal government, you have funding coming from the municipal government, whether that's, in the city of Toronto or whatever municipality you're in, and then you'll have funding from the province. And what I will be focusing on today is funding in the province of Ontario, specifically under the ISO. And what's so challenging and also interesting at the same time about incentives is that you're constantly learning about it. So EC and Poppy, that Trillium Fund, like, I'll be honest, I had no idea. I had no idea that grant existed, even though I've been working with incentives for so long. It's just money can come from so many different ways, and a lot of times it's not coordinated at all by the government. So these are all separate bodies. They market to different industries and different groups. So I'll talk about my expertise, which really has to do with provincial funding, both ISO and Enbridge. But with the amount of time that we have, I'm just going to focus on ISO. The federal government, a lot of their incentives and grants are large, require amalgamation. So, for example, Canadian Infrastructure Bank, you're looking at over $100 million. That's your project size minimum that you have to amalgamate and put a number of projects together to start getting grants from them. So that's a completely different world. It's comes up every once in a while, but one of the things that's very consistent is provincial funding, or fairly consistent under ISO and Enbridge. So ISO has to do with electricity. If you're saving electricity, you're under the ISO bucket. If you're saving gas, you're under the Enbridge bucket here. Okay, so just stepping back a little bit and give an introduction. Aquila Group is a mechanical and electrical engineering consulting firm. We're located in Toronto, do work across Canada, and we have what we call integrated sustainability. So at the core, we're an engineering firm, and we also do grants and sustainability as part of that. Myself, I've been in the building consulting industry for 15 years, and I previously worked at Toronto Hydro, a department called the Energy Systems Limited, or THESL, which is now defunct. It turned into the CDM department for Toronto Hydro. And I guess another confusing part about incentives is they're always changing. So when electricity incentives in Ontario kind of came out in 20 years ago, it was managed locally with different groups. So when I started, it was BOMA Toronto, Building Owners and Management Association. They actually administered incentives in the GTA. And then the LDC started getting involved, the local distribution companies. So if your LDC, for example, in Toronto is in Toronto Hydro, Toronto Hydro would be handling all of the provincial electricity incentives. And then the ISO, which is the kind of the governing body in Ontario, they took control of the incentives, which is good and bad at the same time. Good as in all the incentives in Ontario now are all the same. So if you're applying on Ottawa, you're applying to in Toronto, you're going to have the same available incentives. They're going to be the same program across the board. Whereas previously, when it was like Toronto Hydro and BOMA that are administering the incentives, they would have different incentives. So every single region, every single city you're in, they would have different incentives that would be available. So that was very, very confusing. So now in Ontario under ISO, it's all the same no matter where you are in Ontario. Here's a sample list of incentives that are available under the ISO, which is, if you go to their website, it's Save on Energy. The biggest one that's been available for the last 20 years is the retrofit incentive. So if you're putting in electrostatic filters, that would go under the retrofit incentive under Ontario, and that incentivizes you at 12 cents or 13 cents per kilowatt hour, or I believe $1,200 per kilowatt. So there's kind of multiple paths under there. There's the EB6 commissioning incentive, incentivizes existing building commissioning and commercial, and also schools, which is relative to everyone here. So that's a very good incentive, incentivizes up to $50,000. There's the EPP program, which has to do with ongoing savings. So that's based off of your performance. There's training incentives. And one thing to note, very important, is the current framework. The current CDM framework is ending this year. So, and they haven't actually announced anything, even though it's close to the end of the year. They haven't announced anything for 2025. So if there's an important message in this webinar, is that if you have any projects that are going to save electricity, I'm highly encouraging you to put in the incentive application this year before these incentives potentially will not continue for next year, for 2025. And it doesn't need to be approved this year. It can be approved in 2025, but as long as you've submitted an application, you won't lose out on the incentives. And then under Enbridge, so when we're talking about Enbridge, we're saving gas. There's the commercial custom retrofit program. Again, all these incentives here may be ending in 2024. They may get renewed for 2025, but we really don't know that for certain yet. So if there's anything that you want to say that will save gas, you want to put those incentives in. Boiler incentives. When you're replacing a boiler, you almost always got, I talk about boilers, I'm talking about gas. When you replace a gas boiler over the last 15 years, you would almost always get an incentive. Typically, you're going from atmospheric to condensing, or forced draft to condensing. Because of legislation, federal legislation that basically requires all new boilers to be condensing boilers. That boiler incentive pretty much ended in this year. It was pretty much October. So if you're going with condensing boiler, unless it's above 90% efficiency, and that more has to do with your return water coming from your boilers, you will not be getting incentive for that. Why does the government give energy incentives? It's important to understand this because it gives you an understanding of the rules and regulations of incentives at a very high level. They're trying to encourage managers and owners like yourselves to complete energy upgrades in your facility. Something new in the last few years is to reduce carbon footprint, to reduce demand on existing electrical infrastructure. So right now there's an incentive that's probably ending this year, but to put in basically free VFDs in certain area codes of Ontario. And that's primarily to reduce demand on existing electrical infrastructure, because it's they have some very old and unreliable infrastructure in certain areas. And the government, in pretty much all the incentives, if there's one thing in common, is that the government really wants to say that you're doing the project because of this incentive money. So what that means is when you put in the application for incentive, you need to get approval before the project starts. If you start the project before approval, in their eyes, it's like, well, you're going to do the project anyways. And there's a lot of, politics and semantics in this. Most of the times you're going to do the project anyways, right? But if to secure that incentive, they have to be able to say, our school board did this project because, the government gave us $50,000 or whatever it is. So always wait until you see that official approval that you're getting the incentive before starting the project. And we've gotten incentives even though you started the project, but at a bare minimum, it's you can't have any sort of equipment on site. So if you're rushing out a project, it's end of the year. At the bare minimum is that do not have equipment on your site before you have incentive approval. That will almost certainly cancel the incentive. The official rules is you can't start the project, but really when they say start the project, what defines that is having equipment on site or new equipment. Role of a consulting engineer when doing an application for incentives is you really need someone who understands how the system works, and doesn't necessarily need to be an engineer. Sometimes you can have an engineer, but it doesn't. They don't understand how that particular system works. So, for example, at Aquila, we work in commercial, institutional, residential, and retail buildings, essentially with building systems, HVAC systems. So that's something we understand. That's how we can, at the foundation, understand where the savings are coming from. We would be the wrong people if you had a industrial building, for example, and you're optimizing the process, the industrial process or the manufacturing process, saving energy through that. We'd be the wrong people to do that. So it's really about having someone who understands the system, that is putting together the application, that's doing the calculations, and that really has to do with making the correct assumptions. Excuse me. So the assumptions are really the foundation of our calculations. So if we don't understand the system, we're not going to make the right assumptions, and we're going to have inaccurate calculations and saving estimates. Another benefit of doing incentives and have someone on board that understands the system is that you have a verified third-party unbiased saving report. And that, I feel like, goes a long way beyond just getting the incentive, is that you can use that third-party report for your own ESG, your own reporting metrics, and it's a fairly powerful backup document than just saying, we think our savings are X, Y, and Z. Another reason to use an engineer on these types of energy savings projects is that, and EC talked about that as well in our presentation, which is great, is that you want to save energy, but you don't want to impact operational goals and requirements. So we're talking about poor indoor air quality, occupant comfort. You don't want to do a project that's going to save energy, but at the same time be at the detriment to your occupants or the building, and reducing ventilation rates below what they should be, or that impacting indoor quality. That's not what these projects are for, and you want to save energy, but essentially in the right way. At the core, in incentive savings, and this has been consistent over many decades, is that they're essentially incentivizing or paying you the amount of your first year savings. So they recently changed the incentive rate from 10 cents to 13 cents. Doesn't quite meet what your electricity rate is right now, but they're that essentially brought it up closer to what your annual average electricity rate is. This chart is just showing you, like, even though you're getting, let's say, $50,000 as your incentive, your operational savings are going to be significantly higher over 25 years, essentially multiplying that by 25. So it's great to get the money and to help the capital costs of your project, but more importantly, it's good to have solid calculations, a solid M&V or savings report, because that is going to set the foundation for how that system is going to operate for many, many, many more years. General application tips. We talked about, golden rules: don't start the project before receiving incentive approval. Can't emphasize how many projects that I've had and unfortunately got canceled because of that. Of course, there's a number of reasons why things need to get started, but the last thing you want to do is to start the project not knowing you're canceling your incentive. Make sure the applicant address is filled out correctly. So they mail out checks, and whatever you put on your application is where they're going to mail it out. So I've never had a huge problem with this, because typically they can modify that a little bit at the end of the project, but it just makes the process so much longer. To get it modified takes sometimes months and months and months. So if you were to get the check way earlier, if you put just pay a little bit attention and put the correct information there. Another thing is to ensure minimum hours are met. Typically, that's like 2,000 hours a year. So if your equipment is operating less than that, and just something to be cautious with, and if you're using applicant representative, to make sure that they understand that the hours are less than what is typical. Some general application strategies. When you put in the application, essentially the government sets aside a certain amount of dollars, even though they haven't paid you out yet, and that project may take 3 or 4 years. They're going to set aside, let's say, $50,000, and you cannot. Let's say your project changes later, and you say, "Oh, we're going to add in, 4 more air handling units." You're not going to be able to get more than, typically it's 10% above that $50,000, so you won't be able to get more than $55,000. So you can change the project a little bit, you can modify a little bit from your initial application, but your dollar amount is set. You have that ceiling. So one strategy we typically use is we overestimate our project energy savings. And when I say overestimate, we say, well, what's the biggest scope that you would do? Even though you may not be looking at 20 air handling units, you're looking at 15, but you may do 5 more for the next year. Then we just put in an application for all 20, and then you get paid at the end based off of what you actually do. Under the retrofit program, there are multiple paths. There's custom versus prescriptive. There's demand versus consumption. Your applicant representative should be guiding you and talking to you about the different paths to take, and essentially maximizing the amount of incentive dollars you may receive. But that's a very important decision to make, because once you put in the application, if it's under custom, you can only do your final submission under custom, and you can't change the prescriptive. M&V costs, it can be very expensive to do M&V. You might have to put in some metering. You may have to have people on site multiple times. So those costs should always be proportional to project savings and incentives. And what I mean by that is, if it's a $5,000 project, you're not going to want to spend $5,000, or if it's a $5,000 incentive, you're not going to spend $5,000 on sub metering. It just doesn't make sense. And that M&V plan or those calculations that are done initially, that's one of the foundations of IPMVP, which is the governing body of M&V, is that, the more the incentive, the more the project savings, that's when you can get into more rigorous M&V and metering. But as it's smaller, then you can do more of an estimate. Under retrofit, there are different thresholds. They're not published, and they do change over time. What we found is that if you're in the six-figure incentive, if you're applying for over $100,000, then you get into a very enhanced M&V. Typically, the reviewer comes to site. There's a lot of documentation required. And then if you're below $20,000, then the M&V requirements are very, very basic. So one of the strategies we have is, like, if you're at those thresholds, right, like let's say you are estimating $105,000 of incentives, then we'll have the conversation. Maybe you want to drop that down to 99,000, just to make your life a little bit easier. And even though you're applying for, $10,000 worth less of incentives, you may save on $10,000 worth of measurement verification or quality assurance requirements. So you want to be cautious about those thresholds, and that's a discussion typically you'll have with your applicant representative or your consulting engineer. Maybe I'll pass that back to you, Ava. Thanks so much.
Thank you again for providing some practical step-by-step guidance on calculating energy savings and navigating the grant process, David. Now that we've heard from all of our panelists, I want to bring everything together. As we close this presentation portion of today's session, I hope that you've all gained actionable strategies to accelerate your ESG and sustainability goals. We've learned from and explored clean air intelligence, some advanced filtration, and then grant funding, and how these three areas can work together to optimize building performance, enhance indoor air quality, and reduce energy costs. So remember that the tools and resources are out there, even though it can be a little overwhelming, but together with strategy and synergy, we can tackle these challenges and make a tangible impact on our built environment. For those that do have any questions, we are entering that period now. I'll ask our panelists to come back if there are any to address, and I will navigate who should receive what question according to what wants to be asked. Okay, so thank you, David, for writing in. The question that we've had is, how does installation of air filters get the custom incentive for peak reduction, as these are consumables and they are worried that they will be removed?
Yeah, perfect. I mean, like, yeah, you're reducing pressure drop with these types of filters, and so even though it's working your air handling unit during summertime, during those peak summer hours, which is what they're incentivizing you to reduce, that will drop. Now, in terms of you can always remove this filter and put in your old filter. That's where the supporting documents come into play. I believe we're just looking at another application, and there was supporting documents that Blade Air provided for the filters being provided for 4 years. So that always helps, but I've never had an incentive canceled because it was a consumable. And when we say consumable, like as in they can easily swap it in and out, it's something that if you provide the right supporting documentation, the government there's a level of trust there, and they will incentivize you. They may audit you, when things can be changed. So, for example, you put in a system that can revert back to its old operation, which is less energy efficient. There'll typically be language in there that says, we can't ask for documentation or do an audit for the next 5 to 10 years or whatever it is. So yeah, there is that potential. Have I seen it? No. But that's how they make sure that you're continuing to save energy not only in the first year but in the years to come. And also as a building owner, you're like it doesn't really make sense for you to revert back to your old inefficient operation.
We had one more question roll in. Hi, David. As a school board, we have multiple sites we're looking to secure funding for, identical projects per site. For M&V requirements, is the 100K that was mentioned in your presentation for each site or for the board as a whole?
It's for the way ISO looks at it is application based. So one of the strategies you may have is you break it out into multiple applications. It's a little bit more administrative, a little bit more effort to do the initial application, but you can stay under that threshold, and typically that's that will in the end be less effort than putting in one big 150K application.
Okay. Thank you guys today for this session. I want to thank our panelists again for joining us, and for all of these attendees and all of you guys for joining us today. I will be following up within the next couple of days with a recording of this entire webinar, along with the slides all attached. So feel free to keep a lookout for one of my emails. And thank you guys again for coming today. I hope you found this very insightful, and have a great rest of your day.